So today we'll be going over solving radical equations and solving rational exponent equations. This is 4.8b, solving radical equations. Here are your steps. Step 1, you're going to isolate the radical term. Step 2, you're going to square both sides. Step 3, you're going to solve for x. And step 4, you're going to check for extraneous solutions. Here is your example. So the first example is the square root of 7x minus 18 equals 5. To get rid of your square root sign, you're going to square both sides to get rid of your sign. Then you are left with 7x minus 18 equals 5 squared. Then to make this simpler for you to read it and understand it maybe a little bit better, you can go ahead and square your 5, and then you are left with 7x minus 18 equals 25. Then from this point, you are going to do your usual algebraic method. You're going to try to isolate your x. So the first thing we're going to do is we're going to add 18 to both sides because you want to do the opposite to get rid of it. So we're going to plus 18, plus 18, 25 plus 18, you have 43. So you now have 7x equals 43. Then you're going to go ahead and you are going to divide 7 on both sides because you're multiplying. So divide by 7, divide by 7. You are then left with x is equal to, and because 43 isn't evenly divisible by 7, you're going to leave it as a fraction so that way it's easier to work with, and that way you don't have to round your decimals. So x equals 43 over 7. From here, to check to make sure that you don't have extraneous solutions, you're going to plug your x back into your original equation. So then you have the square root of 7 times 43 over 7 minus 18 is equal to 5. The first thing that you're going to do, again, square everything to get rid of this sign. So 7 times 43 over 7 minus 18 is equal to 25. What I would do now is I would add 18 to both sides. Plus 18, plus 18, 25, plus 18, 43 again. And they have 7 times 43 over 7 is equal to 43. From here, I would multiply my 7 by my 43 over 7. 7 times 43 divided by 7 is 43. 43 is equal to 43. So therefore, your x is equal to 43 over 7. Now, for this equation here, you have 5 square root 7x plus 4 minus 2 equals 23. Although this one may seem a bit more difficult because you have your numbers on both sides of your radical sign, it's very simple. You're just going to do your algebraic method. So first, I would add 2 to both sides, plus 2. Now you have 5 square root of 7x plus 4 is equal to 25. Then I would divide my 5. Divide by 5, divide by 5. You now have the square root of 7x plus 4 is equal to 5. So 25 divided by 5 is 5. You're going to then go again and square both sides. You're then left with 7x plus 4 is equal to 25. You're going to subtract 4 from both sides, getting ready to isolate your x. You then have 7x is equal to 29. You're now going to divide both sides by your 7. X equals 29 by 7 is 4.14. You're then going to plug this back in to your x and try and see if it matches. So we have 5 square root of 7 times 4.14 plus 4, all under your radical, minus 2 is not under your radical, equals 23. You're going to continue on and do what you did before. Plus 2 plus 2, 5 square root of 7 times 4.14 plus 4 equals 25. Divide by 5. Divide by 5. The square root of 7 times 4.14 plus 4 equals 5. Square both sides. 7 times 4.14 plus 4 equals 25. Now I'm going to go ahead and multiply my 7 by my 4.14. And I'm going to get 28.98. 98 plus 4 equals 25. 28.98 plus 4 actually equals, I'm going to move over to this side, 32.98. That is not equal to your 23. Therefore, this equation would be deemed extraneous solutions. I would call this here your extraneous solutions, and if you remember up here, this is written in red because it's a vocab word that we should know. An extraneous solution simply explains whenever your x doesn't actually fit into the equation that you have written. Moving on to 4.8a, we have solving rational exponent equations. This one is much similar to the 4.8b, just one extra step. So your first step, you're going to isolate the term containing the rational exponent. Your second step, you're going to raise both sides to a power that is the reciprocal of the power in the problem. Step 3, you're going to solve for x. Step 4, you're going to check for extraneous solutions. And step 5, you're going to write the solution. The example here is 4x to the power of 3 divided by 4 equals 108. So the first thing that I would do here is I would divide both sides by 4. So here, divide by 4, divide by 4. So then you have x to the power of 3 divided by 4 equals 108 divided by 4 is 27. And so to get rid of your power of 3 divided by 4 on both sides, I'm going to rewrite my equation this way. I'm rewriting it this way so that way I'll be able to easier isolate my x and then solve. So from here you're going to get x equals 3 to the power of 4. And 3 to the power of 4 is 81, therefore x equals 81. And like before on the previous examples, you're going to plug this number back into your equation. So we'll move over here. 4 times 81, because that's what your x was, to the power of 3 divided by 4 is equal to 108. And then you, from there, to rewrite it to see it in a more simple way, you can have 4 times here, and all of this will be to the power of 3 equals 108. Then from this point you're going to get 4 times 3 to the power of 3 equals 108. And then you will go back to your simple algebraic method. You will use 3 to the power of 3, which is 27. 4 times 27 equals 108. 27 times 4 is indeed 108. And there, you've checked it, that's right. So your solution is that x equals 81. So here you see you're solving rational exponent equations and you're solving of radical equations. Both use similar steps, just one different here. Both are very simple and easy to use.